The divided sky. In the war for the soul of the universe, two anomalies stand as pillars. The bullet cluster is the smoking gun for dark matter. The ghost galaxy, DF2, is the death blow for modified gravity. For decades, we've treated these two objects as if they belong to the same category, as if dark matter is just a universal dust scattered across the stars. But they missed a glaring omission in the data: energy density. On one side, a low-energy system at rest. On the other, a high-energy collision screaming through the vacuum at 4,000 kilometers per second. At first glance, it looks like an energy density problem. But the deeper state variable is how that energy is organized through compaction and kinetic stress. When you look at the energy loading of the system, the mystery starts to look like a state change. Think of space-time as the water in this bowl. When energy is low, the vacuum is a fluid. It ripples. It gives way. But move that mass at extreme velocity, and you flood the system with energy. Look at the edges. Look at the swirling turbulence. That energy creates a natural resistance, forcing the entire system into a state of extreme tension. At this level of energy loading, the vacuum isn't just nothing. It is a responsive medium under extreme kinetic stress. It's a medium that is starting to push back. It has become thickened, viscous, and is approaching a stiffened phase. Yet, CDM and Mond treat these two states, the calm and the chaotic, as identical. They are wrong. This isn't a new invention. Einstein's theory already tells us that motion, energy, and geometry cannot be separated. Project Coeus extends that logic. Under sufficient kinetic stress, the vacuum response is no longer fluid-like. It changes phase. It stiffens. While resistance simply opposes motion, impedance defines the system's total reaction to energy flow. This is the law of vacuum impedance. When clusters collide, it's like a racing tire blowing off a metal rim. The rubber tire, the gas, is shredded and diffuse. It decouples and drifts as a low-density cloud, but the cluster cores are the metal rim. Because of their extreme density and velocity, they are already in a pre-stiffened vacuum state. In this framework, the lensing peak does not require unseen particles outrunning the gas. It arises from the solid phase vacuum response carried by the high-stress branch. Here lies the grand irony. Astronomers call this the bullet cluster. But under cold dark matter theory, there is no actual bullet here. Look at the image. The leading edge is sharp. The standoff distance is defined. The fragment reads like a coherent projectile moving through a medium. And that is the problem. Under the standard picture, the gas is collisional and braking, while the dark component is collisionless and continues forward. At that point, the system is no longer one mechanical object. Project Coeus argues that this coherence is not an illusion. It is the signature of a state change. So why does the total structure still read like a single, coherent bullet event? A collisionless mass component can source gravity. A gas shock can create a front. But neither one by itself provides a material phase boundary or a mechanical account of bullet-like structural coherence. Project Coeus argues that this coherence is not an illusion. It is the signature of a state change. To have a bullet, you need a solid phase. You need structural integrity carried by the vacuum itself. They tell us the case is closed because of simulations. But to explain this one image, the standard model must invoke a stack of coincidences. rare merger kinematics, velocity reinterpretation, and additional plasma physics just to keep the front from shredding. This is not a clean victory for the consensus. It is a layered rescue structure. Early models found a collision this fast to be extraordinarily rare, 1 in 10 billion probability. To save the theory, they did not resolve the underlying tension. They redefined which speed counted. The shock moves at 4,500 kilometers per second, but the subcluster itself is reassigned a speed of only 2,600. The bullet is slowed on paper until it fits the simulation. This is the simulation trap. They are matching pixels, not physics. Even after the velocity is reinterpreted, the front still requires additional stabilizing plasma effects to preserve its coherence. The standard model offers a convoluted alibi, but it lacks a unified mechanical law. We reject the tuned result. We have provided the math of a responsive vacuum where structural coherence is a single-phase supported state, not a collection of separate coincidences. This reveals the law of states. Galaxies are not merely collections of matter, they are occupants of a vacuum phase. Systems like DF2 and even the stripped gas clouds within the bullet cluster occupy the same fluid side branch. They are diffuse and low velocity. Because they lack the energy density needed to trigger vacuum resistance, they remain in the fluid phase. This is the deeper irony. Once the gas in the bullet cluster is separated from the high-stress core, it begins to behave like a ghost galaxy. It appears Newtonian because the vacuum has not been forced to stiffen. Conversely, objects like Dragonfly 44 and the high-speed cores of the bullet cluster sit on the opposite side of the divide. Their extreme compaction and kinetic stress cross the threshold, triggering the solid-state vacuum response. They do not have more matter. They have a fundamentally different relationship with space-time. Yet the internal makeup of a galaxy is only half the story. To truly map the universe, we must look beyond the structure itself and into the environment it occupies. This is the network effect. A galaxy's vacuum state can be influenced by its local neighbors. DF2, for instance, sits in the dynamical environment of the massive NGC 1052, a relationship that may bias its local vacuum state toward the fluid branch. Standard models like CDM and MOND tend to treat galaxies as isolated systems or as members of a single universal law. Project Coeus argues for a more connected reality. The vacuum is not a void. It is a unified, responsive matrix. And while the exact mathematical resolution of these local network influences remain the next frontier, the implication is already clear. The state of a galaxy is never only its own. True science honors the null hypothesis. The particle hypothesis has not earned privileged status after repeated null results, while a covariant mechanical alternative now exists. We are not asking for belief. We are asking for a fair scientific audit. If the anomalies are structured, the theory must be structured too.